Today we're going to be studying functions. We are going to be able to determine whether a relation is a function, use function notation and evaluate functions, and find the domains of functions. First, we need to know what a relation is. A relation is a pairs of quantities that are related to each other by some rule of correspondence. That rule could be anything. It doesn't matter what the rule is. Sometimes we won't even know it. My example here is the area of a square to its side length. So if I tell you that the side length of a square is 2 feet, then you can determine that the area of that square is 4 feet. These two numbers are related because of this rule. A function is a set of relations that assigns each element from the domain to exactly one element in the range. Now, domain is just a fancy way of saying the input values, and range would be the output. Let's look at a picture to help us understand. I'm going to say that this box is my domain, or my input, and this box here is my range. Each element in the domain has to have an element in the range. Now, I don't know how these numbers are related, and honestly, I don't really care at this point. But the key thing is, if this relation is going to be a function, then every element in the domain can only have one element in the range. So if I take this input of 4, and I get 11, but sometimes I get 14, then this relation that I have here would not be a function. So as long as each input has exactly one output, then this situation would represent some kind of function. The key is that every number in the domain is used, and they are each only used once. Each input must have exactly one output. So in my picture right here, I have not used the inputs of 2 and 3. Therefore, I cannot say that this is a function because I don't have output values for 2 and 3. If a number in the domain is not used, then it cannot be a function. If a number in the domain maps onto two different numbers, meaning that it has two outputs, then it is also not a function. You'll be given several situations that you have to determine whether or not you are given a function. Sometimes you're given a graph or a picture. If you're given a graph, it has to pass the vertical line test. Let's look at this first picture here. Each input has to have exactly one output. Our inputs in a graph will always be our x values. So I'm looking at each individual x value, and I'm trying to determine if all of these x values have only one y value. So as I travel along my graph, I'm noticing that every input value I have, or every x, only has one y. So this would represent a function. Let's come over here. If I look at my input values on this particular graph, some input values have more than one output, or more than one y. This does not pass the vertical line test, because if I were to draw a vertical line through the x's, it crosses the graph in more than one place. So this is not a function. Here, as I draw vertical lines, I notice that each vertical line only crosses the graph once, so this would be a function. Sometimes we're given a simple list of coordinates. To determine if I have a function out of these coordinates, I have to look at the x value. because I only care about my domain. And I examine them. 2, 4, 6, and 2. Right away, I can say that I do not have a function because the input of 2, or the x value of 2, has 2 outputs. It has 3 and it has 10. So this is not a function. And finally, we could be given a simple equation. If we are going to determine if this represents a function, we have to isolate the y. Make sure to focus on all of our rules of algebra. The first thing I'm going to do is subtract x squared from both sides to try to isolate the y. Now y is not completely by itself. To get y by itself, I'm going to have to get rid of the square. To do that, I'll square root both sides of the equation. Now remember your rules of algebra. Whenever you square root both sides of the equation, you have to account for the positive and the negative value. So that's why we include the plus or minus. So how does this tell us that we have a function or not? Let's think about it. Let's say that I have an input value of 2. So I plug in 2 for x. Negatives 2 squared plus 9. 2 squared is 4. Negative 4 plus 9 is the square root of 5. Now I still have to account for the plus and minus. So y could equal the square root of 5, or it could equal the negative square root of 5. So notice we have 2 outputs for 1 input of x equals 2. Which means that this cannot represent a function. Anytime you see this plus or minus, that's a clue to you that you do not have a function, because you will have at least 1 input that has 2 outputs. Please write down any questions that you have, and we will continue this in class tomorrow.